Hello friends of astrophotography. With this video I wanted to show you a possibility to improve the dynamic range of your images. And what that means, I'm also gonna demonstrate you starting with these 4 images on the title page. Here this photographer Luke Bellani demonstrated that if you take 4 seconds or 15 seconds or 60 seconds or 340 seconds exposure from the Orion Nebula, you're going to see quite different things. If you take short exposures, you see only the center of the nebula, and then successively you see more of the outer, weaker part of the nebula, but the center will be overexposed. And that's what is meant with dynamic range. You can't put that as high as you may wish often. So the outline of today's video is: what is the problem? I've already shown you that. I will show more examples. Then what is the basic idea of HDR? Some of the next steps that I will take, or maybe other people too, to try it out. And then an acknowledgement. Here you can see 2 pictures of a landscape. One is actually without HDR and one is with HDR. So in the one without, you can see the sun and the sky, and the landscape is completely dark because of the dynamic range of the image. Whereas on the right hand side example, you can see lots more information about landscape, about this fields that has been mowed recently, and trees, these kind of things that you can't really see as much on the left hand side image. And seems to be a good solution, and maybe we can extend this idea to astrophotography. So again, the problem is, again with the Orion Nebula, either you see the center and maybe the trapezium stars, these 4 stars, well, but not as much the weaker nebula around it. Or you can see the weaker nebula, but the center is completely overexposed, or how people say, burned in the image. That's often if you have bright stars. Here also the bright stars, they look fine here, and they look too bright than in the longer exposure. Same thing if you do planetary astrophotography. Here somebody took a short exposure picture of the Saturn. Then Saturn can be seen easily, but you don't see the moons. Whereas on the right hand side you can see the moons, or at least think you see them, and the Saturn is completely overexposed. By the way, there's also some chromatic aberration, which is not a problem of the telescope here, but the problem of the, probably Saturn was still quite low in the atmosphere. And there's also some smear of the moons that I don't know if it's a tracking problem or something. And here is how people measure dynamic ranges of cameras. And the dynamic range is measured in stops typically, and these are the stops that you have on the lenses when you stop down the lens. Either you take full aperture or you stop it down, and these factors tend to be enormous, how you can stop it down. But in the astrocameras you normally don't have more than, say, 14-15 stops, which is already quite good, but often it can be quite a bit below that. And this number of stops, this dynamic range, is given more or less by the range between the read noise of the chip and the full well capacity of the chip. So you need a couple of electrons to be reliable, to be reliably higher than the read noise, and there's not more than so and so many electrons that you can store before the pixel is just full and won't take any more electrons. And the electrons are more or less proportional to the photons that you collected. So that's the aim, to improve that to maybe, if you can improve it by 2 stops or 3, that could improve the image quite a bit. And some people may think it has to do with stretching, but this is not actually true, because with stretching you can make things more easy to see in a picture, like this Barnard's loop here in the Orion. But actually, if it's not in the pre-stretched image, you can't see it in the post-stretched image either, because you need reliable differences between the gray values in the gray and in each color. Otherwise, you're not gonna see smooth details or structures in an image. Stretching is nice to make it more visible, but it's not something you can witch around with. So the basic idea is to use HDR. And what is that? For each pixel in the image, you kind of make an experiment how the image behaves in short and long exposure times. Or you could also say with more and less lighting. And thereby you can improve the dynamic range. But how do you get that in the same image? Probably you could just stack it. But there are also specialized softwares that do this in post-processing, like easyhdr, which is listed in the description. And there you just feed in images of different exposures, and then easyhdr is gonna calculate a final image, and the final image should be quite a bit better in dynamic range than the images you fed in, even the ones of the perfect exposure time. So that's quite a nice idea. It's still a bit tedious if you have to do this post-processing, although people go at lengths with post-processing and do much more complicated things, often, especially to improve dynamic range of their image, like unsharp masks or things like that. The next steps, there is, to my knowledge, one company that already does astrophotographical cameras that have HDR pre-programmed, which is Touptek. And so far it does it for 2 cameras, which is the 585, actually the mono and the color version, I think, and also this planetary camera, the 662. And as you can see in the example here for the 585, the camera normally has 12 bits, and after HDR conversion it has 16 bits, which is very useful to to be able to store the better image. It has more reliable differences in brightness. I haven't tried it out yet, but I would love to do that in some challenging objects like, yes, for example, Orion Nebula, and also in planets with this camera. And the point is that you could also leave away some steps that people use in post-processing, like removing the stars, because the stars are not gonna be as bright in the resulting image, and the details don't have to be boosted as much either, because then the image has this natural, relatively wide dynamic range. How did I come to this idea? Actually, by discussion with Rainer Alt. And he said, why don't astrophotographers use HDR? And I asked him, what is HDR? And then he said, maybe you could just vary the exposure times. And then it stayed in me for a couple of years, and then I made some research, especially when I fell over these cameras and read HDR and then thought, I've heard from this before. So if you're interested in Rainer Alt and his music, for example, he's also in the description of this video. So thanks a lot for the attention, and stay curious.